So we can say then, after examining that, is a straight line and by that we mean constant slope, cannot be drawn through all the error bars and pass through the origin. Therefore, D is not proportional to n. So next we're asked to draw a best fit line through the data points. So we can, this is tricky. So what we're trying to do is come up with a line that we can draw smoothly, a smooth line. It needs to be smooth. It needs to be one line. And so we could practice. What I recommend doing is setting your hand on your page and taking your pencil, extending it outward, and then kind of trying to figure out how to swing an arc that will give you a straight or a smooth curve that will go through it all. So that's all right. It's not ideal. I'll practice that. I'll do it again. So that one I missed the error bar there, so I'll take that out. There, so that was kind of smooth and it goes through all of the error bars. Now, sometimes what students will do is they'll kind of like try to sketch it like this and do this kind of thing. That's just always wrong. You never get credit for doing that. It's just got to be one smooth line without any breaks in it. And so it takes some practice to do it fairly smoothly. All right, so there's our best fit line. Now, we've got d squared equals kn. So whenever we have an equation like that, we're given like d squared equals kn, we're going to try and linearize it. So immediately we should be thinking y equals mx, in which case n should be the x-axis and d squared should be the y-axis, and in that way k equals m. Okay, error bars are not shown for the first, are shown for the first and last data points. So there's that size and that size. The size of them changes. Okay. Calculate the percent uncertainty in d squared. So using the graph on the prior page, so we want the uncertainty in d squared. So the u percent in d squared. Okay, well, how do you get d squared? D squared is d times d. So the u percent in d squared will be the u percent d plus the u percent d. So what we need is the u percent d. So u percent d is going to be equal to the absolute uncertainty over the mean value times 100. So going back to the first graph, wait a minute, we already know the absolute uncertainty. The error bar, the uncertainty we already figured out is plus or minus 0.08. So we have 0.08 divided by the value that goes with that. So we got that plus or minus 0.08, which was the same for all of them. Well, the value of number 7 is this right here. So we've got 1.24, so this is 1.2. It goes up by 0.04, so 1.24, and it's about halfway. So I would say about 1.26. And let's just check that again, 1.26, 0.24, 0.28, and it's about halfway, so 1.26. And that works out to be 0.063 And so that then taken is going to be u percent d plus u percent d, and that then is 0.063 times 2. So that gives us 0.126. And we didn't multiply by 100, so that's going to give us times 100, and that's going to give us 6.3%. And so coming back up here, 6.3% times 2 is 12.6%. And getting it some kind of significant digits here is about 13%. Is the percent uncertainty in D squared. So now, state a piece of evidence that supports D squared is equal to Kn. Well, in this case, we can draw a straight line. It passes through all the error bars and the origin. So we say a straight line, constant slope, can be drawn through all the error bars and pass through the origin. Therefore, D squared is proportional to N. All right, so use the graph offsets to determine the value of the constant K as well as its uncertainty. Well, we went a little bit out of order here, but let's go back to our Oizerga for this graph. And our origin is 0, 0. Our y-axis is D squared. X-axis is N. The intercept, the y-intercept is 0, 0. So that's both the x and the y-intercept. So at n equals 0, D squared equals 0. We can read values of D squared and N. The gradient is D squared over N. And the area is D squared times N. And the equation we were given was D squared equals Kn. So K then is D squared over N, which is, we can see, the slope of this line. So what we are looking for is the slope of the line. Now, the way we want to show this on a graph is to label this delta y and put our point pair there, 12, let's see, 2.5. Let me figure out the scale over here. 1, 2, 3, 4, 5. So 0.1. So we've got 2.5, 2.6, 2.7, 2.8. And the delta x, in this case, is 12. So we're going to say explicitly K is the gradient. So m equals delta y over delta x. And we have a delta y of 2.8 minus 0 all over 12 minus 0. Is 0.2333 repeating. And so if we were to report that to two significant digits, that would be 0.23 is the slope is K. Now, we usually should do the units, but I notice that the unit is right here. So we have D squared over N, and D squared is centimeters, so centimeters squared over N. So the units of K are centimeters squared. And that's that question.